Minute Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannett, and this is Minute Math, and today we're learning about solving rational equations. We're going to solve each equation and remember to check for extraneous solutions. So, if I was given this equation, 3m squared is equal to m minus 4 over 3m squared plus 2 over 3m squared. Okay. Well, first thing I'm looking at here, I see a lot of fractions, and what I want to do is see if I can combine these two fractions. So I'm going to combine them here. So 3 over m squared is equal to, since they have the same base, I can add them together, keeping that same base, 3m squared. And the numerator is m minus 4 plus 2. Okay? Now we can simplify that when we have, 3 over m squared here is equal to negative 4, or minus 4 plus 2 is minus 2. So m minus 2 over 3m squared here. So my next step is I can cross multiply, okay? But what I'm going to do is, well, I'm going to cross multiply in a sense, but in reality I could just multiply. You can't cross multiply, but I know if I multiply the 3m squared to both sides here, the m squareds are going to cancel. So I'm just going to multiply both sides by 3m squared. And what that does is cancel the 3m squareds right there, and then these m squareds will cancel, leaving me with just a 9 on the left is equal to m minus 2. Okay? So then I'm going to add a 2 to both sides, give me 11 equals m, rewrite it so m comes first, and m equals 11, and there we have our answer. But we need to check it now. Check for our extraneous solution. So here's my little check here. Fit it right there. Check. I'm going to plug, I'll rewrite the whole thing. 3m squared equals m minus 4 over 3m squared. Let's plug 11 in for m. 3 over 11 squared equals 11 minus 4 over 3 times 11 squared. Okay. Well, here's a little trick. Ready? So if you don't know what 11 squared is, that's fine. Okay. It's 121. But so if I have 3 over 121, and what I'm going to say in a second, you'll see, is watch it. So 11 minus 4 would give me, I can't add right now. Oh my goodness, drawing a blank there. 11 minus 4. Oh, we forgot the other parts here. No wonder I'm like, this isn't going to work. 3m squared here. And then we have plus 2 over 3 times 11 squared. Fantastic. So now we have 11 minus 4, which is a 7, right? Or we can, 7, over 3 times 11, which is 121, plus 2 over 3 times 121, 11 squared. Now, the 11, these are the same base, we can combine them together. 3 over 121 is equal to 9 over 3 times 121, right? 7 plus 2 is 9. And then from there, 9 divided by 3 comes out to be 3 up top. So we have 3 over 121 equals 3 over 121. They're equal. What I was saying now is kind of small. Hopefully you can see that. Okay. What I was saying about the 11 squared and leaving it like that is we didn't actually have to distribute the 3 times 121. I like to keep it separate sometimes if I know if I'm going to cancel it out. And since I saw 11 squared there and a lot of 11 squared, I probably could have just left 11 squared and saw that they were the same, right? It would have been 3 over 11 squared equals 3 over 11 squared. Either way, we confirmed m equals 11. 1 over n equals 1 over 5n minus n minus 1 over 5n. Okay. Well, since we have like terms here, right, 5n and 5n, I know I can combine those fractions, so I'm going to do that. 1 over n equals, well, 5n in the denominator, 5n, and then 1 minus parentheses n minus 1. Okay? So we're subtracting that. Now, when I subtract, I'm going to subtract that numerator. So combine the denominator. We distribute the minus sign out, and that ends up being 1 over n equals 1 minus n plus 1 over 5n. Simplifying that, we have 1 over n equals 1 plus 1 is 2, so 2 minus n over 5n. What I'm going to do now is I'm going to multiply both sides by 5n, leaving me, or canceling that out, 2 minus n on the left, and the n's here end up canceling, leaving me with just a 5, or 2 minus n on the right and 5 on the left. So now I'm going to subtract the 2 to both sides, giving me 3 equals negative n. I divide by negative 1, and I'm going to rewrite it, flipping it here, n equals a negative 3. Okay? So we have 3 divided by negative 1 is a negative 3, and I flipped it, having n come first, because that looks nice and neat. So now we need to check that answer. We need to check it. So we're going to rewrite my equation, 1 over n equals 1 over 5n minus n minus 1 over 5n. And let's plug negative 3 in for n. So we have 1 over negative 3 equals 1 over 5 times negative 3 minus negative 3 minus 1 over 5 times negative 3. Well, 1 over negative 3, can't really do anything there. Let's simplify the right-hand side. That's 1 over 5 times negative 3 is negative 15. Minus negative 3 minus 1 is a negative 4. And then 5 times negative 3 is negative 15. Okay? We can combine our bases, right? Because they have the same base, we can subtract them together. So we have 1 minus negative 3 equals 1 minus a negative 4 over negative 15. Okay? Correct. Yeah. 1 minus a negative 4. Yeah. Looking good. So then we have 1 minus negative 4 is plus a positive 4, right? Plus a positive 4. So we have 1 over negative 3 equals 5 over negative 15. 5 divided by negative 15 is negative 1/3. And there we have it. All right, negative 1/3 does equal negative 1/3. My left and right hand side were equal, confirming that my final answer is n equals a negative 3. 1 over 3x squared equals x plus 3 over 2x squared minus 1 over 6x squared. But what I want to do here is I want to have these two to have the same base. And for them to have the same base, I need to multiply this one here by a number. Now that number is going to be 3 over 3. Okay? 3 over 3. Why did I choose 3 over 3? Well, 3 times 2 gave me that 6, right? So then I have 6x squared in the denominator, and that's really what I was looking for. I put 3 in the numerator because, well, 3 divided by 3 is 1, and multiplying anything by 1 over 1, which is just 1, or 3 over 3, which is just 1, doesn't change the item itself, okay, the term itself. So I'm not really changing it, I'm just making it look different. Okay, so I'm going to have a negative, or a 1 over 3x squared on the left, and then I'm going to leave that 3 distributed up top, x, or not distributed, 3 over x plus 3 there, but I have 6 now, x squared, and then we're minusing 1 over 6x squared here. Okay, now what I can do is combine these two here. So in combining them, I have 1 over 3x squared on the left equals, now up top I'll distribute as well, so now I have 3x plus 9 minus 1 over 6x squared. Now what I'm going to do is bring the 6x squared to this side, so I'm going to multiply both sides by 6x squared. Over 1, really. That eliminates the 6x squareds here, eliminates the x squareds right there, leaving me, oh well, 6 divided by 3 comes out to be 2. So we have 2 here equals, and then 9 minus 1 is 8. So we have 3x minus, or plus 8. Whoops, plus 8. Okay? So now we're solving for x. Pretty simple at this point. We subtract 8 to both sides, giving me a negative 6 here equals 3x. Divide by 3 to both sides, and hopefully we can see flipping it here. You're getting better at that. Divide by 3, negative 6 divided by 3 is negative 2, and x is equal to a negative 2. Okay, kind of wrote that up here. So now we need to check that work, check to see if we have an extraneous solution. So we check that, so we rewrite our equation, 1 over 3x squared is equal to x plus 3 over 2x squared minus 1 over 6x squared. We plug negative 2 in for x, so we have 1 over 3 times negative 2 squared equals negative 2 plus 3 over 2 times negative 2 squared minus 1 over 6 negative 2 squared. Okay, oof. Negative 2 squared comes out to be 4, okay? So we have 1 over 3 times 4 there, and negative 2 plus 3 is a 1, and negative 2, I'm going to kind of do it all together here, negative 2 squared is a 4 times 2 is a 6, 8, do I even know math, is a 8 positive 8 minus 1 over negative 2 to the second power is a, oh my goodness, again, 4 plus 6 times 6 is 24, okay? And then top's 1, 1, we're good. And so now we need to combine these two fractions. Well, 1/8, I can rewrite that to be 3 over 24, right? And multiply both by 3 over 3, so we can subtract the two fractions, 1 over 24 here, okay? Because, yep, we're good. So I have now 1 over 3 times 4, which is 12. Subtract them here. 3 minus 1 is 2, so we have 2 over 24. We combine the two fractions, 1 over 12. And 2 divided 4 is 1/12. There we have it. Left and right were equal. Fantastic. Confirming that x is equal to a negative 2. 4 over n squared is equal to 5 over n minus 1 over n squared. Okay. Right now, I want to combine these two fractions. I can't at the moment because, well, this has a base of n, that's a base of n squared. So what I'm going to do is multiply this 5n by n squared, or n over n. Okay, so multiply this by n over n. If I can fit that in, n over n. We'll fit it in there right there. Okay, but multiply by n over n, I'm left with 4n squared on the left. Doesn't change that. But I have 5n over n squared on the left, on the right side, or left of these two, minus 1 over n squared. What that allows me to do is combine these two fractions together. When I combine the two fractions together, I'm left with 4 over n squared again on the left is equal to 5n minus 1 over n squared. They have the same base. Multiply now n squared to both sides. Eliminating the n squareds right there. These n squareds get eliminated. Now I have 4 equals 5n minus 1. Pretty easy to solve now. Add a 1 to both sides. 5 equals 5n divided by 5. Rewrite it here. N equals 5 divided by 5 is just 1. There we go. Okay? Toss it in there. Okay? So now I have n equals 1. I need to check that. So to check it, I'm going to rewrite my equation. 4 over n squared is equal to 5 over n minus 1 over n squared. Well, if n is 1, I can quickly just plug it in. 4 over 1 squared equals 5 over 1 minus 1 over 1 squared. Okay? 4 over 1 squared is 1. 4 over 1 is just 4. 5 over 1 is 5. Minus 1 over 1 squared, which is 1, is 1. 5 minus 1 is 4. Fantastic. Left and right hand side are equal. Great. Confirming n equals 1 is my final answer. 3n plus 15 over 4n squared equals 1 over n squared minus n minus 3 over 4n squared. Well, I see that they don't have the same base, these two fractions, the 1 over n squared and n minus 3 over 4n squared. So I need to make them so they have the same base so that I can combine them. I can subtract them. Well, all I need to do is really have a 4n squared down here. So if I multiply this by 4 over 4, which is essentially 1, that'll give me a 4n squared in the base. Okay? So what I'm going to do here is I have 3n plus 15 on the left over 4n squared is equal to, now multiply that 4 over 4n squared minus n minus 3 over 4n squared. Great. Now I can combine these two, and in combining the two, I have the same base, so I have 3n plus 15 over 4n squared here equals 4 minus n, distribute the minus sign, plus 3 over 4n squared. Now, to get the 4n squared out of the denominator, I'm going to multiply both sides by 4n squared over 1, really, right? 4n squared over 1. That eliminates the 4n squared on the right and the left, actually, giving me 3n plus 15 on the left equals, and then 4 plus 3 is 7, so 7 minus n on the right. Let's bring our n's together, so I add an n to both sides, and I subtract the 15 to both sides. That leaves me with 4n on the left, and on the right a negative 8, so when I divide by 4 to both sides, I'm left with my final answer, which is n equals negative 8 divided by 4, which is negative 2. Okay? So now I need to check that. Check that. So we have 3n plus 15 over 4n squared is equal to 1 over n squared minus n minus 3 over 4n squared. We're going to plug negative 2 in for our n squared. So for our n, sorry. So we have 3 times negative 2 plus 15 over 4 times negative 2 squared is equal to 1 over negative 2 squared minus negative 2 minus 3 over 4 times negative 2 squared. A lot to do here. 4 times negative 2, or negative 2 squared, comes out to be positive 4. Times 4, which is 16, so we have 16 in the denominator here, and 3 times negative 2 is negative 6, and negative 6 plus a 15 is a positive 9. So we have 9/16 right there, is equal to, well here, 1 over a positive 4, minus, up there, negative 2 minus 3 is minus 3 is a negative 5, so negative 5 right there, over this down here is 16, right? Negative 2 squared is positive 4, 4 times 4 is 16. Well, 1/4, I can rewrite 1/4 to become, right, I want it the same base as 16, 4 over 16. So we have 4 over 16 here, and then minus the negatives plus a positive, 5 over 16. And we have 9 over 16 right there. 4 plus 5 is 9. So we have 9 over 16. We can combine the bases because they're the same. 9 over 16. Fantastic. Left and right hand side are equal. Great. Which then confirms our final answer here, which is n equals a negative 2. 1 over 2n squared plus 5 over 2n is equal to n minus 2 over n squared. But what I see here is I want to combine these two fractions, but they don't have the same base. Since they don't have the same base here, I need to rewrite this 5 over n to n to have the same base. So I want to multiply it by n over n. n over n. I fit that in right there as the equal sign. Okay? And so in doing so, I have 1 over 2n squared plus 5n over 2n squared now is equal to n minus 2, keep it like an exponent, over n squared. Now that they're the same base, I can combine the two, and I have 1 plus 5n over 2n squared, which equals n minus 2 over 2 over n squared. Excuse me, just n squared on the left, the right side, over n squared. Okay? So now what I'm going to do is multiply both sides by 2n squared over 1. 2n squared over 1. That eliminates the 2n squared here, giving me 1 plus 5n. But then, just the n squared part's eliminated, so I have the 2. I distribute the 2 across, and I have 2n minus 4 there. Okay, distribute that 2 across. So now let's bring our like terms together. So I'm going to subtract 2n at both sides, and I'm going to subtract a 1 at both sides. That gives me 3n is equal to, right, negative 4 minus 1 is negative 5. And then I'm going to divide by 3 to both sides, giving me my final answer here, which is n, I'll write it right here, n equals negative 5/3. So we got a fraction here. So now we're going to check that fraction. Okay, let's go check our fraction. So we have our check here. Plug it back in. We have 1 over 2 times negative 5/3 squared plus, not equal to, plus 5 over 2 times negative 5/3 is equal to negative 5/3 minus 2 over negative 5/3 squared. And I ended up just not rewriting the equation, just plugging the n value, or negative 5/3 in for n from the beginning. Save some space here. So let's simplify this out. We have 1 over 2 times negative 5/3 squared is positive 25 over 9. Okay, plus here 5 over again. Distribute the 2 across. We have 2 times 5/3, which is negative 10/3, which is equal to, on the right hand side here. Okay, right hand side, negative 5/3 minus 2. Well, minus 2 can be the same thing as so in 5/3 here. Minus 2 we can write as a fraction. Now the 3 is a base, so it's the same thing as minus 6/3 over negative 5/3 squared, which is a positive 25/9. Okay, let's go practice our fractions here. Okay, so let's multiply this out. We have 1 divided by 2 times 25 over 9 is 50 over 9. Plus, here now, here's a little trick. 5 divided by a negative 10/3. And that comes out to be, in a sense, right? If you want to see one little example right here, right? 5 really divided by negative 10/3 is the same thing as 5 times negative 3/10. That helps me see that fraction right there is a negative 15 tenths right there. Okay, that is equal to, which I didn't give myself enough space here, so I have to kind of rewrite that. Sorry about that. So we have 1 over 50 over 9 plus what we found here to be a negative 15 over 10 is equal to, simplify this fraction, 5 thirds, negative 5 thirds minus 6 thirds is negative 11 thirds over 25 ninths. Okay, so now we're going to keep on going, our fractions here, using the same technique we did over there, that 1 divided by 50 ninths, right? 1 divided by 50 ninths comes out to be 9 over 50, plus here, negative 15 over 10, is equal to, and now we can apply that technique right there. So if we have a negative 11 thirds divided by 25 ninths, we can flip that to be negative 11 thirds times 9 over 25. Okay, 3 cancels with the 9, gives me a 3 right there. Okay, and that kind of helps maybe see this a little bit, and it's a negative 33 over 25. Okay, so how good are we at making our fractions here? Well, we can rewrite this, and it's the same base, right? Multiply that by 5, and in doing so, we have 50 on the denominator, and we combine them. We have 9 plus, what's negative 15 times 5? Negative 15 times 5 is 75, so negative 75 right there. Okay, negative 75, yeah, that's correct, that's correct. So negative 75 equals negative 33 over 25. Okay, I'm going to rewrite that right here because I really have no room now. 9 plus a negative 75 is a negative 66. Hopefully we can see this now, over 50 is equal to negative 33 over 25. Negative 66 divided by 50, we can divide both by 2, give me negative 33 over 25, and that equals negative 33 over 25. Check, left and right are equal, we're good. Negative 5 thirds is our true final answer. X minus 6 over x is equal to x plus 4 over x plus 1. Well, first thing I'm going to do, I'm going to see if I can combine these two right here, right? So when I want to combine the two, okay, I need to have the same base. So in doing so, having the same base, I rewrite 1 to be something with x. So if I multiply it by x over x, and really that 1's like over 1, I would just get x over x there, which is equal to 1, but allows me to combine these two fractions. So we have x minus 6 over x equals x plus 4, excuse me, over x plus x over x. Now that we have the same base, I can combine the two, giving me x minus 6 on the left over x is equal to x plus 4 plus x over x. Now I can multiply both sides by x, eliminating the x on the right side and the left side, giving me x minus 6 on the left equals, well, x plus x is 2x, 2x plus 4 on the right. So now, let's go bring our x's together. So I'm going to subtract 2x on both sides, and I'm going to add a 6 to both sides. That leaves me with x minus 2x is a negative x equals a positive 10, divided by negative 1 to both sides, and I have x by myself here as a negative 10. Okay, fantastic. So now we're going to check that. I'm going to plug negative 10 in for my x. So we can rewrite the equation here. X minus 6 over x equals x plus 4 over x plus 1. Let's plug negative 10 in. So for x, we have negative 10 minus 6 over negative 10 equals negative 10 plus 4 over negative 10 plus 1. Okay? So now let's simplify that. Negative 10 minus 6 is a negative 16 over a negative 10 is equal to negative 10 plus 4, which is a negative 6 over negative 10 plus 1. Well, 1 is really negative 10 over 10, right? So I'm going to write that to be instead of plus 1 and negative 10 over 10, same fraction. That allows me to combine the two fractions, give me negative 6 plus negative 10, which is negative 16 over negative 10, and we have negative 16 over negative 10. Now, of course, I know I can simplify both of these fractions, but I've already shown that they're exactly equal left and right. We can say we're done there. We've shown that. Check. We're good. Confirming that negative 10 is not an extraneous solution, but our real solution. 1 over 2n plus 1 over 4n squared is equal to 1 over 4n. Well, I want to combine these two together, but when I combine them together, I need to have the same base. So to get the same base here, to have a 4n squared right there, I have to multiply that by 2n. And when I do it, I have to multiply the numerator and denominator too. Because 2n over 2n is just 1, doesn't change it, but 2n times 2n is 4n squared. So now I have 2n over 4n squared, right, plus 1 over 4n squared equals 1 over 4n. Now that the same base, I can combine them, giving me 2n plus 1 in the numerator and 4n squared on the denominator is equal to 1 over 4n. Now I'm going to multiply both sides by 4n squared. And what that will do is eliminate the 4n squared down here, eliminate the 4's right there, and this n gets eliminated with the squared, giving me just n on the right and 2n plus 1 on the left. Okay? So now I'm going to subtract an n to both sides, and subtract a 1 to both sides, giving me, well, just n by itself, and on the right-hand side, a negative 1. Right? 0 really minus 1, negative 1. So I can rewrite this here to be n equals negative 1. And there's my answer. So now I need to check that. So to check it, I'm going to rewrite my equation. 1 over 2n plus 1 over 4n squared equals a 1 over 4n. Let's plug negative 1 in for n. So we have 1 over 2 times negative 1 plus 1 over 4 times negative 1 squared equals 1 times 4, 1 over 4 times negative 1. Well, simplify 1 over 2 times negative 1 is negative 2, so we have a negative 1 half right here, plus negative 1 squared is positive 1 plus a 1/4 equals, in this case here, a negative 1/4, right? 4 times negative 1 is a negative 1/4. Negative 1/4. So what's negative 1 half plus 1/4? Hopefully you do that in your head. That's a negative 1/4, and left and right hand side are equal. Fantastic, confirming that we don't have an extraneous solution here, and n equals negative 1 is our final answer. 6b plus 18 over b squared plus 1 over b is equal to 3b. Okay? Well, first thing I'm going to do, I'm actually going to bring this 1 over b to the right. So I'm going to subtract a 1 over b there. And in doing so, I guess I'm not going to write it like that. I don't want the fraction right there. It's a little confusing there. What that does, we have the same base over there. So we can combine those two. So I have 6b plus 18 over b squared on the left equals, well, 3b minus, so we can see a little note here if you need a little note here, right? 3b minus 1 over b is just 2 over b, right? So we have 2 over b right there, okay? A little note there, what's going on there when I subtracted them. So we have 2 over b. So now when I multiply b squared to both sides, b squared is going to eliminate it here. This b eliminates with that squared, leaving me with just a 2b on the right and a 6b plus 18 on the left. I now can bring my b's together, so I'm going to subtract the 2b to both sides. And I'm subtracting 18 to both sides. There's nothing there, it's 0, so we just have a negative 18 on the right, and 6b minus 2b is 4b on the left. Now, when I divide that, when I divide by 4 to both sides, I get b by itself, and that fraction simplifies. Well, negative 18 over 4, both divided by 2, is negative 9 halves. And there we go. So now I need to check that, okay? And when I check this, make sure your fractions are all in line. So I'm going to put b in, negative 9 halves in for b, so we have 6 times a negative 9 halves plus 18 over negative 9 halves squared plus 1 over a negative 9 halves equals 3 over a negative 9 halves. Okay. So let's be careful with our fractions here. Okay. Well, let's go simplify some of this stuff. 6 and 2 become a 3 right there, right? And 3 times negative 9 is negative 27. So we have negative 27 plus 18 over negative 9 squared, negative 9 times a negative 9 halves times a negative 9 halves. I'm squaring that, so we have actually 81 over 4. Okay, and that little fraction there. Plus, okay, now if you know a little note here, a little note right there, okay, a little note here, that 1 divided by negative 9 halves is the same thing as 1 divided by negative 9 halves, which is 1 times a negative 2 over 9, 2 over 9, which makes it easier to see. And so now we just have a negative 2 over 9 right there. And we can apply the same thing by flipping that over, multiply this right-hand side to get negative 6 over 9. Okay, so let's go add these two together. What's negative 27 plus 18? Okay, negative 27 plus 18 comes out to be a negative 9. Negative 9. So we have negative 9 here over 81 divided by 4 plus negative 2/9 equals, we can simplify this a little bit, that's negative 2/3. Okay? So applying the same thing we did here with the division, we know that it's the same thing as negative 9 times 4. Negative 9 times 4. So watch this. I'm going to actually do it like this. Ready? Negative 9 times 4 over 81 plus a negative 2 over 9 equals negative 2/3. Okay? Well, negative 9 and 81 eliminate, leaving us just a 9 there. So we have negative 4 over 9 plus a negative 2 over 9. That comes out to be negative 6 over 9 when I combine them. Negative 2/3 right there. And we know that negative 6 over 9 is equal to negative 2/3. So rewrite that here, negative, we'll squiggle here. Negative 2/3 does equal negative 2/3 if it fits on the page. Hopefully, fantastic. It does. Great. And so our left and right hand side are equal. And so we confirm our final answer, which is B equals a negative 9/2. 1 over 2x minus x minus 1 over 2x squared is equal to 3 over x. Well, what I need to do now is I need to multiply this fraction by x over x. And what that does, when I multiply it out, right, I'll put a parenthesis there, multiply it out, it gives me the same base. So we have x over 2x squared minus x minus 1 over 2x squared equals 3 over x. Since they have the same base now, I can combine the fractions, I can subtract them. So I have x minus x, distribute the minus sign, gives me a plus, so we have x right there, plus 1. And that's all over 2x squared, and that's equal to 3 over x. I now can multiply both sides by 2x squared. That eliminates the 2x squared on the left-hand side, and then on the right-hand side it eliminates the x, just giving me now 3 times 2, x is 6x, and the right-hand side, well, x minus x is 0, plus 1 is 1. I then divide by 6 to both sides, giving me 1/6 is equal to x. So right here, x equals 1/6, nice and neat. Excuse me. So now I got to check my work. So I'm going to plug 1/6 for every single time I see an x. So I have 1 over 2 times 1/6 minus 1/6 minus 1 over 2 times 1/6 squared equals 3 divided by 1/6. Okay, so let's go check that. Well, 2 times 1/6 is 1/3. So we have 1 over 1/3 minus here, 1/6 minus 1 is a negative 5/6 over, well, 1/6 squared is 1 over 36, okay? And times it by 2 is 1 over 18. So we have 1 over 18 right there equals, now a little trick here we do is 3 divided by 1/6 is the same thing as 3 times 6 over 1. And 3 times 6 is 18. So we have an 18 actually right there. Okay, we can combine that, I can do that same trick with this thing here, giving me a 3 here. So 1 divided by 1/3 is just a 3. And then our subtraction signs kind of eliminate to make a positive sign. We have minus and negative, positive. So now what I'm going to do here with that little 5/6, right? 5/6 divided by 1 over 18 is the same thing as 5/6 times 18 over 1. 6 goes into 18 3 times. Fantastic. So we have 15 here, right? 5 times 3 is 15 equals my 18 that's on the right. 3 plus 15 is 18. 18 does equal 18. Left and right equal. Fantastic. No extraneous solutions. And my final answer is just x equals 1/6. The big one. 1 over b squared minus 7b plus 10 plus 1 over b minus 2 is equal to 2 over b squared minus 7b plus 10. Okay. Well, whenever I see a complicated problem like this, and I see a quadratic down in the denominator, I'm thinking, well, maybe can I factor that? That's what I'm kind of thinking here first. And so I think, can I factor this out? And maybe have something that's a b minus 2 is kind of a factor thing. Wow, that's part of it. So it actually can. Well, two numbers multiply to be 10, but add to be negative 7, and that's negative 5 and negative 2. So I can rewrite this to be factored b minus 2 times b minus 5 plus 1 over b minus 2 equals, 2 over, and this is the same one, b minus 2 times b minus 5. Okay? Well, now from here, okay, now what we're going to do is, well, I need to have the same base so I can combine these together, right? Now, I do have the same base on the left and right, and so I could subtract them to both sides, and this one, actually, I will. I think I'm going to do that. So I'm going to subtract to both sides here. Well, this whole thing, so I'm going to subtract a 1 over b minus 2, b minus 5 to both sides, and I'm going to subtract over here 1 over b minus 2 and a b minus 5. Now, since these are the same base, right, I can rewrite on the left-hand side just b minus 2, 1 over b minus 2. And then over here, okay, what I'm going to do is, I'm going to rewrite to kind of show what's going on, but it's 2 minus the 1, 2 minus the 1, the numerators, and the denominators stay the same, b minus 2 times b minus 5. Okay? So, what I can do now is simplify that. Well, 2 minus 1 is just 1, right? So, I can write it as just 1 over b minus 2 here equals 1 over b minus 2 times b minus 5. Okay. So what I'm going to do now is I'm going to multiply both sides by this denominator, b minus 2 times b minus 5. Okay, so let's go rewrite this up here. Okay, we have 1 over, a little more space there, 2 equals 1 over b minus 2 times b minus 5. And what I'm going to do here is multiply both sides by that denominator, b minus 2 times b minus 5 to both sides. Multiply by just b minus 2. That arrow, I got a little too happy with that arrow, but it's okay. B minus 2 times b minus 5 over 1. That's multiplication right there, so that's what's going on right here. Okay, so now in doing so, I eliminate this here, leaving me with just a 1 on the right, and the b minus 2's end up canceling. So I have a b minus 5 now. Okay, so I have b minus 5 equals just 1. Well, that's simple. Now I just add a 5 to both sides, and we're left with b equals a 6. And there we have it. We have our final answer. But they told us we need to check that. So let me write a b equals 6 as my final answer here again. So I have one more space. I'm going to erase here, gives me some space here, so I can simplify this. I'm going to leave the equation. So make sure I have some space here. There we go. Quick, good, isn't it? And so now I'm going to plug in the b equals 6 and for my b for my check. So now I'm going to check this. Okay, so let's plug 6 in for b. So we have a 1 over 6 squared minus 7 times 6 plus 10 plus 1 over 6 minus 2 equals 2 over 6 squared minus 7 times 6 plus 10. Okay, well, in checking this, let's go deal with it. 6 squared is 36, so we have 1 over 36 minus 7 times 6 is 42 plus 10, or there plus 1 over 6 minus 2, which is 4, equals 2 over the same denominator that's right here, okay, which is 36 minus 42 plus 10. Okay, let's simplify this. Well, think about this if you want. 42 plus, negative 42 plus 10 is negative 32. And then 36 minus 32 is 4. So we have a 1/4 here plus 1/4 equals 2 over, well, in this case, 4, right? Because we already did the same thing. This denominator came out to be 4. Okay? And now we simplify this. Well, 1/4 plus 1/4 is 1/2. And 2/4 simplifies to be 1/2. And there we go. We checked it. We checked our answer, b equals 6. We plugged it back into our original equation. And that became the left and right to be true. So now we can confirm that 6 is a real answer and not an extraneous solution. 1 over x squared minus 3x plus 1 over x minus 3 equals 3 over x squared minus 3x. Well, what I'm going to do here, I'm going to do a few things, okay? So what I'm going to pull out, if I pull out here, okay, I see this x squared minus 3x. And I think if I pull out an x, which I can, I have x times x minus 3. And what I notice now about that is the same denominator that's written right there, or similar, right, the x minus 3. The only thing is there's an x on the outside. So how can I make these denominators the same? Well, I can do that if I multiply this by x over x. That leaves me x over x times the x minus 3 in the denominator. So we can see how this, if I divide the x's, gives me the same thing. But what that does now is give me the same base here. And the same base here, I got to plot an x here, x times x minus 3. Now that they're all the same bases, I can add these two together. And so I just have a 1 plus x over x times x minus 3 now. I can combine them. Equals 3 over x times x minus 3. Well, what I'm going to do now is multiply both sides by this denominator to eliminate it. Multiply both sides, so x times x minus 3 here, over 1. X times x minus 3 to both sides, over 1. Eliminates it there, eliminates it there. Leave me with 1 plus x equals 3. Okay, subtract a 1 to both sides. And I'm left with x by itself equals 3 minus 1, which is 2. And there we have it. Rewrite it here, nice and big in the middle. Okay, but now I have to check it. Let's go check our work. So let's go check it here. So to check it, I'm going to rewrite my equation and I'm going to put 2 in for my x's. So I have 1 over 2 squared minus 3 times 2 plus 1 over 2 minus 3 equals 3 over 2 squared minus 3 times 2. Okay? So let's just simplify this. We have 1 over 2 squared is 4 minus 3 times 2 is 6 plus 1 over 2 minus 3, which is a negative 1, right? Equals 3 over 2 squared, which is 4 minus 6 again here. So let's simplify here. We have an 4 minus 6 is a 2 or negative 2, so we have a negative 1 half there plus a negative 1 equals 3 over a negative 2. Okay? Well, negative 1 half plus a negative 1 is a negative 3 halves. So we have negative 3 halves here equals a negative 3 halves. And there we go. Our left and right hand side are equal, which is great and fantastic. And that confirms that 2 is a real answer, not our extraneous solution. 6 over p equals 1 over p minus 5 minus p plus 4 over p squared minus 5p. Okay, well, what I'm going to do here is I need to see, okay, how can I combine these two? And I see that p squared minus 5p. I think I could factor that out. So I have p plus 4 over there over, if I just factor pull out a p, I have p minus 5 there, right? And so what I can do now, to make it the same denominator, p times p minus 5, I have to multiply the numerator by p, and 1 times p is p. So now we have the same denominator, right? P over p is just that 1, and I have p minus 5 right there, and I have 6 over p here. So now what I'm going to do is, well, I can combine the two. The denominator is still p times p minus 5, so the numerator is p minus p, minus, keep the subtraction distributing, minus 4, okay? And then we have 6 over p on the left. And the right hand underneath, we have p times p minus 5, which I'm now going to multiply on both sides, p times p minus 5, times p minus 5. Multiply that to both sides, let's do it over 1, why not? That cancels out this here, cancels out this p, and if I distributed that across, 6 times p is 6p, and 6 times 5 is 30. So 6p minus 30 equals p minus p with a 0, and we have a negative 4 right there. So if I add a 30 to both sides, I'm left with, well, 6p equals negative 4 plus 30, which comes out to be a positive 26 divided by 6, and p here by itself, we can simplify 26 divided by 6, both are divisible by 2, is 13 over 3. So now I need to do my check. So I'm going to rewrite my equation right here, check, with 13 over 3 in for p. So I have 6 over 13 over 3 equals 1 over 13 over 3 minus 5 minus 13 over 3 plus 4 over 13 over 3 squared minus 5 times 13 over 3. So what I'm going to do is I'm going to use my calculator to help me out here. So I have 6 divided by 13 divided by 3, and I have a fraction of 18 thirds here. This one here, that 1 over, I'm going to simplify the denominator, 13 divided by 3 minus 5, and our fraction here is a negative 2 thirds minus 13 over 3, the numerator there, plus 4 is a fraction of 25 thirds the numerator. The denominator, I'm going to do this whole denominator at once. 13 divided by 3 squared comes out to be 18.777. Repeating, minus 5 times 13 divided by 3. And that fraction comes out to be negative 26 over 9. So let's go simplify everything. We'll keep this 18 thirds right here. And then 1 divided by negative 2 thirds, I believe is at negative 3 halves, but we'll double check here. 1 divided by 2 divided by 3 is 3 halves. Yes, a negative 3 halves. That's correct. Minus here. And what's 25 thirds divided by a negative 26 ninths? And we have here a negative 75 over 26. Okay. Well, that becomes plus a positive. So times it by negative 1. And we add that plus a negative 3 halves. And that comes out to be right here an 18 thirds. Or 18 over 13, sorry. And we have 18 over 13 right there. And my left and right hand side were equal. Fantastic. Confirming that P equals 13 over 3 is my final answer. It's not extraneous. 5x minus 20 over x squared minus 9x plus 18 plus 1 over x minus 6 equals x minus 4 over x squared minus 9x plus 18. Okay. Whew, it's a doozy of a problem. Well, first thing I'm going to think about here is, can I factor these out, the x squared minus 9x plus 18? And I believe I can. Okay, what's the numbers that add to be negative 9, but multiply to be 18, and that's negative 3 and negative 6. So I'm going to rewrite this to be 5x minus 20 in the numerator, and then x minus 3 here, and x minus 6 plus. Now I can rewrite this. I'm going to make it the same. I want it the same, have the same base. So I'm going to multiply this by x minus 3 over x minus 3. And then we're left with what's been done. There's a 1 up here. We can write that up 1 through times 1 times x minus 6. What was left there, same base, equals x minus 4 over, factor out that denominator, which is x minus 3, right, which we already did, x minus 3 times x minus 6. Okay. So now that we have the same base, I can combine the two, the numerator and the denominator. So now I have 5x minus 20 plus x minus 3 over the denominator, x minus 3 times x minus 6. And that's equal to x minus 4 over x minus 3 times x minus 6. It's getting crazy here. Well, now I can multiply both sides by that denominator. And what that does is basically eliminate them. So we have x minus 3 times x minus 6 over 1, multiplication, and then x minus 3 times x minus 6 over 1, multiplication. That eliminates this, leaving me, and I can simplify this, 5x plus 6, x is 6x, and negative 20 minus 3 is minus 23, equals x minus 4. Much simpler problem now. So what I need to do now is simplify this. Well, let's go subtract an x to both sides, and then add a 23 to both sides. And that leaves me with a 5x equals a negative 4 plus 23, which is a 19, and then divided by 5. And we're left with the fraction here. Let's go right over here. X equals 19 over 5. Okay? So I'm going to kind of write it over there. And there we have it. But now I need to check my work. So to check my work, since I don't have space here, I'm going to erase here for a second. So to check it, I'm going to plug 19/5 in for every single one. Plug 19/5 into every single one of my x's. So we have 5 times 19/5 minus 20 over 19/5 squared minus 9 times 19/5 plus 18 plus 1 over 19/5 minus 6 equals 19/5 minus 4 over 19/5 squared minus 9 times 19/5 plus 18. Okay? So now I'm going to use my calculator. I'm going to simplify basically everything one step, or the numerator here. So 5 times 19 divided by 5 Subtracting 20 from that, so this becomes my, oh my gosh, I can't believe I used my calculator. 5's cancel, give me 19, 19 minus 20 is negative 1. Okay? I just rushed too quickly to the calculator. Denominator, 19 fifths squared minus 9 times 19 fifths plus 18, my fraction, gives me a negative 44 over 25, plus here, 1 divided by 19 fifths. Insert parenthesis there, I'll need it. Minus 6, the denominator, comes out to be a fraction here of negative 5 over 11, equals, equals this here, 19 fifths minus 4. The numerator comes out to be a negative 1/5 over the denominator, which we already found right here to be negative 44 over 25. So let's go see if we can simplify this. What's this one plus this one? So the negatives cancel out, so it's positive. So we have 1 divided by 44 divided by 25, which is going to be 25 over 44. Yeah, fantastic. Plus negative 5 divided by 11. Simplifying this, and I get a fraction here of 5 over 44. Let's check this one here. Negatives cancel, so we have what's 1/5 divided by 44 divided by 25. And we have the same fraction, 5 over 44. My left and right hand side were equal, which confirmed that this answer, x equals 19 fifths, is not an extraneous solution, and is my final answer and is a real solution.
One over 5k squared plus 2k minus 6 over 5k plus 2, and that's equal to 6 over 5k squared plus 2k. Okay. One thing we know about our fractions is that we can only combine them when they have the same denominator. So all of our denominators have a k, obviously a 5, but notice we have a k squared and a k here, and this is just k and then a 2. Okay? So we have 5k squared, 2k, 5k plus 2, k squared plus 2k. So I take this one right here, this 6 over 5k plus 2, and I multiply that by a k. Okay? So I multiply by a k over a k. So this one here, so you can see it. If I multiply that by the marker part here, a k over a k. So what is that going to do? Well, essentially, the other parts stay the same, so we still, if I come down here, 1 over 5k squared plus 2k, okay, minus, well, k times that 6 will be 6k. We distribute this k to both parts there in the denominator, and so now we have 5k squared plus 2k equals, lastly, 6 over 5k squared plus 2k. So now all of our denominators are the same, which makes it easier to solve. So let's go to the left side of the equal sign. We can combine the two now, so the denominators are the same. So they will share the same denominator when they're done, 5k squared plus 2k, okay? But then the numerators, we can subtract them together. Well, they're not like terms, so it's just 1 minus 6k. And let's bring down the right side. 6 over 5k squared plus 2k. Alright. Well, now we can cross multiply, okay? So when we cross multiply here, okay, what that's going to do is help us get our final variable by itself. So in doing so, I'm going to cross multiply, okay? But notice the way I do it. I'm not actually going to FOIL or distribute. I'm just going to leave it here as 1 minus 6k times 5k squared plus 2k equals the right-hand side, 6 times 5k squared, almost for an x there, k squared, plus 2k. Okay? Now, I'm going to divide both sides, ready, by this 5k squared plus 2k. Normally, I would just start distributing right now, but I know if I divide that to both sides, that's going to kind of cancel out. I like to cancel as much as possible. So, if I divide that 5k squared plus 2k to both sides, these will cancel right here, and this will cancel. Okay? So, because they're exactly the same. And so, if we continue our work here, we're left with just this 1 minus 6k that was in the parenthesis, and that's just equal to, really, just 6 by itself here. So this, super complicated, just became pretty easy. So let's keep going. Subtract a 1 to both sides, and we're left with a negative 6k equals, well, 6 minus 1 is 5, divided by negative 6, and we're left with our final answer here of just k equals negative 5, 6. But they told us we need to check for extraneous solutions, so let's do that. So I'm going to rewrite my original equation minus that pink part there, okay? And I'm going to leave everything on the left and right hand side, but I'm going to substitute negative 5, 6, and 4k. So let's do that here. We're going to check. This is our check right here, okay? So we have 1 over 5, that's me the k, plus 2 times that k, minus 6 over 5 times again that k, plus 2, equals 6 over 5 times again that k squared, plus 2 times that variable there. Okay, so just so we can see it, we're going to put k in for each one of these values. We have k here, k there, k here. Oh, sorry, not k. Well, k, yes, but we're checking the extraneous solutions. Common mistake, I would just rewrite the first problem. I've seen students do that as an answer. Negative 5, 6 for each one. Negative 5, 6. Negative 5, 6. Negative 5, 6. And negative 5, 6 here. Okay? So, what I want to do now is, well, let's go square. We're going to simplify and see if the left and right hand side are equal. So, negative 5, 6 squared, or 1 over, excuse me, don't forget that. Negative 5, 6 squared. Well, negative 5, 6 squared is negative 5, 6 times negative 5, 6. Multiply the numerators across, and we have a 25. 5 times 5 is 25, and 6 times 6 is 36. Plus, well, here we can simplify a little bit. 2 and the 6 become a 3 in the denominator. We have a negative 5 thirds here. Minus 6 over 5 times 5 is a 25, but it's negative, so we have a negative 25 over 6 plus 2 equals, all the way to the right, 6 over, well, again, same thing as we did here, right? 5 times 25 over 36 plus, and then we found was negative 5 thirds. Okay. So now let's solve, let's keep going. We're going to keep trying to check, see if the right and left hand side are equal. So I'm going to use my calculator to help me out here. Okay, so we got some good fractions, but let's do 5 times 25 over 36. So 25 divided by 36 times 5, and then as a fraction is 125 over 36. I should have known that. I don't know if it would simplify. Okay, 125 over 36 minus, right, plus a negative is same as subtraction, 5 thirds. Minus here, well, 6 over, what's negative 25 over 6 plus 2? So negative 25 divided by 6, we add 2 to that, and then as a fraction, because I just like keeping everything as fractions, that's a negative 13 over 6. Alright, and the right hand, this last thing, the denominator will be the same. 125 over 36 and then minus 5 thirds. Okay, let's keep going. What's 125 over 36? 35 divided by 36 minus 5 thirds. And as a fraction, okay, so we have 1 over, and this is 65 over 36, minus, well, we have 6 divided by negative 13 divided by 6, and that as a fraction, thanks to our calculator, is a negative 36 over 13. And the right-hand side, well, we still have the denominators the same, so it's 6 over 65 over 36. So let's keep going here. Remember, this is plus a negative, or a minus a negative is plus a positive. So 1 divided by 65 divided by 36. Okay, and then I am going to add, so let's do it all in one step here, because I'm kind of running out of room, plus 36 divided by 13 as a fraction, and that should give you the fraction 216 over 65. The right hand side here, what's 6 divided by 65 divided by 36, and that as a fraction is 216 over 65. So now, what does that mean? The left and right hand side are both equal to, meaning we have a true solution. And so our final answer here is k equals a negative 5 over 6. 6 over n squared minus 6n plus 8, and that's equal to 1 over n squared minus 6n plus 8, and that's minus 1 over n minus 4. Okay, so what I want to do here, well, my first step is I want to see if I can get the same denominator across the board. Well, here we have a quadratic and here we don't, but I can probably factor, right, the denominator, and it probably gets something with n minus 4, so let's do that. And these two are clearly the same. We have 6 over, well, what two numbers multiply to be 8 but add to be negative 6? It's a minus 4 and a minus 2. So we have n minus 4 here and n minus 2. That multiplies out to be n squared minus 6n plus 8. So again, same denominator here. We've already done the work once. N minus 4 times n minus 2. So now this one on the right. Well, what I'm going to do here, I know I have a 1 over, right? 1 over, and I have the n minus 4 here. But if I multiply this by n minus 2 over n minus 2, I now have, and I can pretty much combine this, right, to be one big fraction. That's multiplication by 1, but it doesn't really matter. The same denominator across the board. That means we can add and subtract. That's our goal with fractions, okay? So, left-hand side, to keep the same, 6 over n minus 4 times n minus 2. Right-hand side, though, we have 1, or the denominator is the same, right? N minus 4 times n minus 2. But the numerators, we have 1 minus, and we're subtracting, don't forget, the numerator, and that's the n minus 2 here. So n minus 2. Okay. Well, what can we go? Well, let's simplify this numerator a little more if possible. Okay? So what I'm going to do is actually, well, I'm going to do 2 steps in 1 here. I'm going to take this here, this denominator, and I'm going to actually multiply it over here. I'm not going to cross multiply. I could if I wanted to, but I'm not going to. When I bring that over here, you'll see something. So we have 6 times, and I can multiply up across that here. N minus 4 times n minus 2 over n minus 4 times n minus 2. The right-hand side, the numerator, that's what's left over here, and we have 1 minus n minus 2. So remember to distribute that minus sign. We have 1 minus an n, and then minus a negative or minus a minus 2 is plus a positive, so we have plus 2 here. And there's nothing in the denominator, and if you want to put it over 1, you can. All right? For the left-hand side, this is pretty neat. N minus 4's will cancel, N minus 2's will cancel. So we have 6 now completely by itself here, right? Everything cancel, and that's equal to, well, 1 minus N plus 2. Well, 1 plus 2's adder-like terms is 3, right? We have 3 minus an N. Well, let's get N by itself. Subtract 3 to both sides. And I think you can do the rest here. 6 minus 3 is 3, equals a negative N. So I'm going to write my answer here. Divide both sides by negative 1. Don't forget that last step. And we have N equals a negative 3. But they told us to check for extraneous solutions. So when I do my check here, okay, I'm going to rewrite my original equation, but every single time instead of an N, I'm going to put a negative 3. So we have 6 over negative 3 squared minus here, minus 6 times a negative 3 plus 8 equals 1 over a minus 3 squared minus 6 times a negative 3. I always don't make the fraction long enough. Plus 8 minus 1 over N, which is a minus 3, minus 4. Now we're going to see if the left and right hand side are equal. If they are, we're good. So we have 6 in the numerator over denominator, negative 3 squared, positive 9. Minus 6 times minus 3 is a minus 18, plus 8 equals, well, same denominator, so we should have the same thing out here. 9 minus a negative 18 plus 8. And then all the way to the right, 1 over negative 3 minus 4 is a negative 7. Okay? Keep this going here. Okay? Well, minus a negative, same thing as adding a positive. Okay? And then we also plus an 8 here. So 18 plus 8 is a 26. 26 there. Plus 9 is 35. So we have 6 over 35 here equals 1 over, same thing's going to happen, over 35. And then we have minus a negative, which is plus a positive, plus a 1/7. Now, I don't feel like going into adding fractions. Let's use our calculator really quickly here. 1 over 35. I think actually I can't believe I'm using my calculator, but it's okay. I've already committed. And we have on the right hand, 1 over 35 plus 1 over 7 is a 6 over 35, which is equal to the left hand side, 6 over 35. The left and right hand side are both equal to, meaning that N equals negative 3 is my final answer. 4 over A, that's an A, not a 9, is equal to 1 over A squared plus 4A minus A plus 3 over A squared plus 4A. Okay. Well, first thing I want to do here, I look and I want to make all the denominators the same. I kind of look at the right-hand side, and I see I have A squared plus 4A for both of those denominators. But this one's just an A. I know on the right-hand side, I can rewrite that by pulling an A out. And in doing so, I would have, well, I have A here, let's do A plus 4, times the A. If I pull it out to the right there, right? That would give me, if I multiply it back in, A squared plus 4A. So let's just do the same thing over here. A plus 3 up top, but in the denominator, A plus 4, and then times an A. So why do I do that? Well, what I can see here, I have this A in the denominator, and if I multiplied that by A plus 4, I would have the same denominator. So if I kept this as 4 over A, and multiply that by, well, A plus 4 over A plus 4, and really this becomes one full fraction, right? Multiplication going on there. And now we have a denominator that's the same across the board. Okay, A times A plus 4. So now if I add my fractions, whatever I need to do, it doesn't really change anything, okay? So let's go see what we can add. Let's focus on the right-hand side first. Same denominator, there's subtraction. So now we just have 1 minus, make sure you distribute the minus to both parts, minus an a, and then, remember, minus a 3, or plus a negative 3, however you want to see it, over a plus 4 times a. All right. Right-hand side, same thing. I'm just going to leave it here. I'm not going to distribute it yet. 4 times a plus 4 over a times a plus 4. Okay? Now, same thing, remember it's just flipped around, but they're the same denominator. Instead of cross multiplying, I am just going to multiply this denominator up here to the left. Now watch this, okay? And I'm not going to simplify, I'm not going to multiply it all out here. So we have 4 times a plus 4 times a plus 4 times a over that denominator, a times a plus 4. And that's going to equal to 1 minus a plus 3. Okay, and actually that one, why not? I can simplify that. Okay, simplify this right beforehand. And, well, 1 minus a plus a negative 3. 1 plus a negative 3 is a negative 2, right? So we have a negative 2 minus an a here, okay? And it's kind of over 1 if you really want to see that. Well, an a plus 4 can cancel here, and so can the a. And that's why I didn't necessarily multiply it out. I knew something wasn't going to cancel. So we now have, well, 4 times a plus 4, and let's distribute that. So we have 4a plus 4 times 4, which is 16, plus 16 equals a negative 2 minus an a. Let's bring our like terms together. A's to the left, numbers to the right. I add an a to both sides, and I subtract a 16 to both sides. I'm left with 4a plus a is 5a, and negative 2 minus 16 is negative 18. Divided by 5 to both sides, getting kind of small. You can fit it right here, and a is now by itself, and it's just negative 18 over 5. All right, now they tell us we need to check for extraneous solutions, so let's go check. And to do that, we have to plug negative 18 over 5 in for a in our original equation and see if the left and right hand side are equal. So let's go write this out here. 4 over a, negative 18 over 5, equals 1 over a squared, so negative 18 over 5 squared, plus 4 times negative 18 over 5, minus a up here, negative 18 over 5, plus 3, over, again, negative 18 over 5 squared, plus 4 times negative 18 over 5. Okay. Now I'm going to use my calculator to solve the rest of this here, because I'm not going to do all these fractions here. It would take forever. So negative 18 divided by 5, or actually let's do the first one. 4 divided by negative 18 divided by 5. And that gives us a fraction of negative 10 over 9. Let's keep going here. Let's focus on the denominator. Negative 18 divided by 5 squared, and that as a fraction is 324 over 25, plus 4 times negative 18 over 5, and we have a fraction of negative 72 over 5. Okay? Right hand side, negative 18 over 5 plus 3, and that as a fraction is a good old negative 3/5. Okay? Over, this denominator will be the same as this one, so 324 over 25 plus a negative 72 over 5. Let's keep going, left hand side, keep it the same, negative 10 over 9. And then as we go to the right, 324 divided by 25 plus a negative 72 divided by 5 is a fraction, so we have 1 over a negative 36 over 25. And we'll do the same thing here. 324 divided by 25. Oh, it's going to be the same denominator, same as the other one. So we have negative 3/5 up top over negative 36 over 25. Keep going. Negative 10 over 9 equals 1 divided by, now you probably know this answer already, but 36 divided by 25 as a fraction. It's going to be flipped around here. But we have negative 25 over 36. Let's be minus here. Let's do it all together. Negative 3/5 divided by negative 36 divided by 25. Typed it in right. Yep. And that as a fraction is 5/12. Okay? Remember the negatives here cancel. So it's a minus. So let's keep going. Negative 10 over 9 here equals what's negative 25 divided by 36 minus 5 divided by 12. I almost put 2 there. That would throw off my answer here. And as a fraction, we got negative 10 over 9. Left and right hand side were equal, meaning our final answer is just A equals a negative 18 over 5. 3 over k squared plus 5k plus 6 minus k minus 6 over k squared plus 5k plus 6 equals 1 over k plus 3. Well, we want to have all the denominators the same so we can add them together. Okay? So what I like to do, well, I see a k plus 3 here, and there's a good chance if I factor, right, the denominator here, that there'll be k plus 3 in there. So let's go do that. We have 3 over, now, k squared plus 5k plus 6. What two numbers multiply to be 6 but add to be 5, and that's 3 and 2. So we have a k plus 2 here, and a k plus 3. Same thing, we have k minus 6 over, same denominator, we can still factor it the same, k plus 2, k plus 3 equals. Now, we can bring this down, we have 1 over k plus 3, but I want to have the denominators the same. So I multiply this fraction by k plus 2 over a k plus 2. We now have the same denominator. We kind of can put that together as one big fraction, and then we have the same denominator across the board. So let's combine the left-hand side. Since we have the same denominator, we can add and subtract the numerator. So we have, well, 3 minus, make sure you distribute the minus sign to both parts, minus k, and then minus and negative is adding a positive, plus 6. Over denominator, just the same. We have k plus 2 times k plus 3 equals right-hand side, multiplying that out, just put out k plus 2 up top, over, now, I can rearrange it so it's the same order, k plus 2 times k plus 3. Doesn't matter. So watch this. This is what I like to do, and it's a little different, I think, than others. You normally would just cross multiply here, but I'm actually just going to multiply this denominator right here up to the left. Okay? I'm going to do it in 2 parts here. So when I do that, multiply up that way. Okay? I'm also going to simplify this. So we have 3 minus k plus 6. 3 plus 6 is a 9. So we have 9 minus a k here, and then bringing this up, k plus 2. And a k plus 3. But I'm not going to multiply it out yet. This denominator, k plus 2, and a k plus 3. And left with just the right-hand side, the k plus 2, which is left over. Now you can put it over 1, but don't worry about it here. These k plus 2's will cancel, and k plus 3's cancel, and that's why I didn't actually multiply it out. I knew they would cancel. Now I'm left with 9 minus k equals k plus 2 here. Let's bring all of our k's together and all of our numbers together. So if we add a k to both sides here, and we subtract a 2 to both sides, we're left with 2k equals 9 minus 2, which is 7. Divide both sides by 2. And we put our final answer here. And rewrite it, k coming first. K equals 7 halves. Okay? So we have k equals 7 halves here, but they told us that we need to check for extraneous solutions. So let's do our check here. I'm going to rewrite my original equation, and instead of k's, put 7 halves, and see if the left and right hand side of the equal sign are equal. 3 over 7 halves squared plus 5 times 7 halves plus 6 minus 7 halves minus 6 over 7 halves squared plus 5 times 7 halves plus 6 equals to, right hand side, 1 over 7 halves plus 3. Now I'm going to be using my calculator a lot here, so make sure I don't make a mistake, and this isn't a problem on how to solve with fractions and stuff and simplify all that. It'd take up all the space, do it all by hand, but 7 halves squared, let's deal with that. Okay, 7 halves squared. So the numerator is still 3, but 7 halves squared as a fraction is 49 over 4 plus 5 times 7 halves as a fraction. Well, I should know this, but whatever. Just keep going. I said I was using my calculator. That's 35 over 2 plus 6 minus the numerator, 7 halves minus 6, and that as a fraction is a minus 5 halves. The denominator will be the same as here, so we have 49 over 4 plus 35 over 2 plus 6 equals, right hand side, 7 halves plus 3, and as a fraction, that's 13 over 2. Alright, let's go add this whole denominator together. We have 3 over 49 divided by 4 plus 35 divided by 2 plus 6. And that, as a fraction, is 143 over 4. Same thing I can assume here with a negative 5 halves over 143 over 4 equals, and let's go write this out. I know what it is, but let's just double check it. 13 divided by 2. And so 1 divided by 13 divided by 2 should be 2 over 13, and it is 2 over 13. It's funny when you have a calculator, you always got to double check, right? So simplify this fraction. 3 divided by 143 divided by 4. And we need an extra parenthesis there. And we have a fraction of 12 over 143 minus, well, negative 5 halves divided by 143 divided by 4. And we have a negative 10 over 143. Okay, and then we have 2 over 13 here still. So 12 over 143. Now this minus and negative, same thing as adding a positive, plus 10 divided by 143 should give us the same fraction on the left and right hand side, and it does. We have 2 over 13 equals 2 over 13. The left and right hand side are equal, meaning our answer was correct. K equals 7 over 2. V minus 3 over v squared plus 3v equals 1 over v plus 3 minus v minus 5 over v squared plus 3v. Now one thing I want to do is make sure all the denominators are the same. Now they're pretty close, but when they all are the same, we then can find a like term here, and or we can add them together, and like term add them together, and help simplify easier. So we have v plus 3 here and v squared plus 3v. If I pull out a v in the v squared plus 3v, I have a v plus 3 inside. So let's do that. So we have v minus 3 up top and then we have v times v plus 3. And I know my v's kind of look like square roots. This one here, this middle one, I want to have something just like it. I have v plus 3 here. If I multiply this fraction by v over v, okay, I then have the same denominator. And when you can multiply v or something over itself, it's really multiplied by 1, so it doesn't change it, but we now have the same denominator, and look, I can make it as one big fraction here if I want. Again, subtraction here, v minus 5 over, do it again, pull out the v, and we have v times v plus 3 here. So now we have the same denominator, we can subtract the right-hand side. Left-hand side is keep the same, v minus 3 over v times v plus 3. Here, well, let's subtract the numerator, which you can, v minus 5. All right, we can distribute that minus sign across, and so we have, well, v minus v, and then minus 5 is plus a positive 5. Plus 5 over that denominator is just now together, v times v plus 3. So now I'm going to multiply both sides by this denominator, or we can cross multiply it, but I'm really going to just bring this side up. You'll see why in a second. And doing so is going to cancel some things out. It makes it a whole bunch easier to use and manipulate. So we have v minus 3 here, and don't distribute it yet, or ever actually, v times v plus 3. And you can put extra parentheses if you want, over v times v plus 3 here, equals, well, v minus v is just, well, anything subtracted by itself is 0, so there's 0 plus 5, okay? Well, luckily, v plus 3 here cancel, v cancels, and we're left with something pretty easy. We have just v minus 3 left over, equals 0 plus 5, which is 5, add a 3 to both sides, and v is all by itself. We can write it right here. So that's v, bear with my v's here, v's equal 5 plus 3, which is 8. But we have to check this, right? They told us to check for extraneous solutions. So let's check. Let's see if that actually was right. So what I'm going to do is rewrite my original equation, but put 8 in for every v, and luckily you won't have to see my v's anymore. So we have 8 minus 3. Let's do it like this. Put a parenthesis. I like to put parentheses around everything that I substitute in. Make sure I bring it all. So we have 8 minus 3 over 8 squared plus 3 times 8 equals, 1 over 8 plus 3 minus 8 minus 5 over 8 squared plus 3 times 8. And I always have a calculator handy because I always make simple little mistakes here. Okay? Now we want to make sure the left and right hand side are equal, so we're going to keep them separate, simplify the left and right hand side individually, and see if they become the same answer. Well, 8 minus 3 is 5 here, right? And then 8 squared is 64, plus 3 times 8, which is 24. We have 1 over 8 plus 3 is 12. 11. See, those are simple little mistakes I always make here. Minus 8 minus 5. Okay, 8 minus 5 is a 3 over 8 squared is 64, plus 3 times 8 is 24. All right, I'm just use the calculator because I don't make a mistake here. 64 plus 24, or let's do 5 divided by, let's do it all at once, 64 plus 24. And that as a fraction comes out to be 5 over 58. Okay, good job, Sean. Over, well, 1 over 11 minus 64, or 3 divided by 64 plus 24. And that as a fraction is 3 over 88. So, left hand side keep the same, 5 over 58. Let's see if the right hand side becomes that. 1 over 11 minus 3 divided by 88. And what do we have here? Oh, we have 5 over 88. Oh, let's just double check, see if I made a mistake here. I have 5 over 88. Let's see. Did anything happen? 8 minus 3 is 5. 8 squared 64. So 64 plus 24. Oh, 64 plus 24. There we go. Found it. This should be an 88. Ah, some of you are probably watching that and be like, wait, what? How did he hit 58? It's an 88 here. I'm sorry. I can't believe. See, little mistakes here, even with the calculator. So, sorry. That was 64 plus 24 should be 88, and that's 5 for 88. So, either way, always kind of double check. Don't just erase everything right away if you make mistakes. We all can make mistakes. Left and right hand side, though, are equal, meaning that our answer was true, and our final answer is just V equals 8. 1 equals 3 over m plus 3 plus 3m over m plus 3. Okay. This one's actually fairly simple for the time being. The left-hand side, I can leave as a 1 for right now. The right-hand side, well, we have m plus 3 and m plus 3, the same denominator, so we can just add them together right now. So let's go do that. Since we have the same denominator, we have m plus 3 here. We add the numerator, and 3 plus 3m. Pretty straightforward. Now, this fraction is hard to simplify, but we know 1 over 1, or 1 is 1 over 1. We can write it like that if you want to see it that way. It really depends on how you want to see it. We can do what's called cross multiply. Now, luckily it doesn't really change much. It just brings the m plus 3 to the left. And m plus 3 times 1 is m plus 3. And 1 times 3 plus 3m is 3 plus 3m. A little easier now, so let's get our like terms together. Let's bring our m's to the right, our numbers to the left. Let's subtract an m to both sides, and subtract a 3 to both sides. Be careful with this though. This is something that students trick up all the time on. These m's will cancel and these 3's will cancel. And 3 minus 3 is a 0, right? So it kind of cancels, but we had a 0 there. 3m minus m is just a 2m. And before you say, oh, there's no solution, whatever, we can still keep going. Multiplication separates 2 and m, so we divide both sides by 2. And 0 divided by 2 is 0, and we have an m. And so my answer here is just m equals 0. Now they told us to check, so let's go check to see if this actually worked. Check for extraneous solutions. To check, we take our answer 0 for m, and we plug 0 in for every single variable in our original equation. So 1 equals 3 over 0 plus 3 plus 3 times 0 over 0 plus 3. So now what we want to do, well, let's go simplify. We'll see if the left and right hand side are equal. If they are, then we're good. So we have 1 equal, that's easy, it stays by itself. And 0 plus 3 is 3. So we have 3 over 3 here, plus 3 times 0 is 0, and 0 plus 3 is 3. Keep simplifying. 1 equals 3 divided by 3 is a 1. Anything divided by itself is 1. And 0 divided by 3 is, well, 0. We have plus 0 here. 1 plus 0 is 1. And so my left and right hand side are equal. What that tells us that we don't have an extraneous solution, and our solution, our m equals 0, is our final answer.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.